sure you sent it at some point, but
Yeah, it was
I just didn't
probably
get a
the
chance to
first
look at it.
file. It was the
Yeah.
first time you were there. So if you go to that day, probably 2 weeks ago, there is a file there that I share with everyone. But I will send it to you anyways. But that's
Okay.
basically, if you can be comfortable doing what is requested in that file, so that's for this week, that would be great. And that's what I would try to do now. I'm taping now. I'm taping this conversation and I send it to you. But basically, you type A is equal, and then you can call that file. So the file is, in fact, what's the name of the file? Star and record number. So I'm gonna call A is equal, and then is a string variable star, and then I have to add this number. But if I do string for IND, right, plus dot save, so I think I'm gonna read, for instance, the first record of GQW. So and then I print A. I get this funny name with a big space there, and that's not it. So I have to get rid of this space. So I'm gonna make this to be to delete all these spaces with the function called string compress, and then I put this string that I want to take all the empty space, and then I do this underscore remove all. And now I have the star. So I could basically, by changing the record number here, 0 or 1, for instance, I could read the record number 1. But when I read, if you look up here, so if I type help, for instance, it's going to give me that I have this string name, and I can then restore A. When I restore A, look up here, I have a W, which stands for wavelength, and S, which stands for flux. So I can plot this nonsense. So I can do a plot WS, and then I get my spectrum. Okay, just a second. Okay, so but let's say that you go to the point that you want to see not just the whole spectrum, but you want to see just a fraction of it. Move this down. So you want to read just a fraction. So you can limit that with the X range. X range, let's say for 400, 4,800 to or 4,700 maybe, to 5,100, and then I'm limiting the visualization. So I'm looking only at one emission line, and then I say, okay, that's cool, that's very cool. But let's say that I want to not only that, but I want to plot all the data I have on this particular star on that particular range, and then for that I could do a loop for n equal from 0 all the way to the number of strings number elements in IND minus 1. So IDL, when you have a string variable or a float array or array or a double array that has certain number of elements, IDL reads from 0 all the way to n minus 1
Yeah.
number of elements. I think Python does the same trick.
Yeah, Python, Java.
Yeah, Java. So that's what I'm doing here. So I'm doing a for loop, and then I'm going to put this ampersand command saying, okay, I'm going to put more commands there. And then I could just say restore, and I will restore these files. Hey, why am I putting your email? Restore. There you go. Restore star string compressed, but here I'm going to put n, right, because it's variable. And then I restore for n equals 0 the star, and then I want to ampersand because I want to plot for in that interval what I'm doing. No, I want to plot in that interval. Control C, and then I Control V, I plot. So it's gonna plot, and since this is gonna go quick, I'm gonna give a wait of a second or so. Wait 1 and 4, and then I got an error because of what? For anybody,
syntax error of some kind.
I think the command I didn't answer correctly. Do begin. There you go. So now I have, so it's going to go through all the different observations, and then you see there is not a lot of variation. You know, the profile is pretty much stable. I could restore a different star, like restore in GQ. I think GQ.
So is the for loop, is that going through just different observations of the same star? Or?
There you go, the same star. So I restore the number of records. For instance, now I and GQ loopi, there are 33 observations. So so the only thing I do, I repeat the same command, except that I will go, and this star varies a lot. Number and star compressed string IND. I think that's it, right? Let me see. Yeah, there you go. So see, this H beta is not like the other one. It has a lot of variability, specifically this absorption here, which is dramatic, something phenomenal. But we already published for this star. But anyway, so that's the idea. If you can follow the file, and I send it to you over the weekend, if you have a time, if you get comfortable, that's great. And then you let me know, and then I can talk to you again.
Yeah, for sure.
Okay.
Okay.
All right.
Is there anything that I missed on Wednesday?
No, I went exactly what I did here with you. I did it with Shaunak. But Shaunak, we set his path correctly. We download process, we download the new ISO, and yeah, we did the same thing. And then we opened the floor. Your dad was not there. Rick was. Lee Rottler submitted an application for Gemini telescope, so he couldn't be there. And pretty much that's it. So 9 o'clock we close it.
Okay.
Okay. All right.
So,
let me know how it goes.
Yeah. One more thing. So
yeah.
For is this the same story that we were in my version of IDL?
Say it again.
Because I see that the array is has 33
yes.
3 elements, right?
Yes.
So is this a different star you're looking at?
That's a different star. It's GQ loopi. Is
Okay,
another star.
okay.
You see that the profile is different, and this star has
Yeah.
a dramatic absorption here, which we try to explain in a paper. Yeah.
Okay, so for TW high, is that also contained in the?
In fact, I do have, but I didn't create an INDTW HYA. So I will create it and I will send it to you. But I didn't create it because I was not interested in that star when I created this record, this catalog. Okay.
So
So I created it and send it to you.
Okay. I took a screenshot of the of what you put in the console so that I can try it myself. And then I'll look at the file that you send me and I'll mess around with it a little bit.
Okay, that sounds good.
Okay.
All right.
Then other than that, that's pretty much it. And next time, what do we plan on doing next time?
Yeah, Wednesday next week. But before, if you get stuck or something, just let me know, then we can try connect somehow.
So once we get this working, what's the next step after this?
Well, I would like to get all this data available online because it's pretty much residing in my machine and would be nice to organize it. But besides that, I would like you guys to go to EASL and download the high resolution data, which is a different ball game because you have much more lines to advance and you have a lot of details that you have to be aware of. So I would like all of us to get some strength developed in the low resolution data because it's much simpler, has much less lines, and then we get to know the tricks in which these lines vary over time, and then when we encounter the high resolution with abundant spectral coverage, then we can just use the skills we learned. Let's say, just let us give us 3 months or 4 months in the low resolution data before we face the high resolution. So by then, you guys are good in IDL or Python, and then things is gonna be a little bit more simpler, I think.
Okay.
All right.
Sounds good then.
Okay. Say hi to your dad.
For sure.
Okay.
Thank you.
Bye-bye.
Bye.
Bye.